Hey, what's up, guys? Okay, so in this video that I want to talk about some problem in the big O because I find that sometimes that people have some difficulty, right, to really write down the proof of this big O, right? Because like you always have some intuition that, for example, like polynomial, right, is less than exponential, or basically that you can like negate a constant term, or basically the log should be like whatever power is less than polynomial. But sometimes that okay, so you might need, if you want to prove it, then some people will have some difficulty. So I want to hope these three examples will give you some feeling, and hope you guys subscribe to my channel. Okay, so in this video, let's just I will like talk these three examples. So the first example that I want to talk is that polynomial, right, is a big O of exponential. Okay, so let's just see. Okay, so what we're going to show is that as a f of n is, let's say polynomial is f of n, there is a small o g of n, where gn is exponential, and this is the same as that we take n goes to infinity, and the f of n divided by gn, which goes to 0. Okay, so what we more precisely, what we need to show is that let's consider k greater than equal to 0, and the c greater than 1, that we want to show that limit n goes to infinity, there the polynomial, let's say n to the k and the c to the n, which is goes to 0. Okay, and you might think, oh, this is trivial, right? Polynomial exponential grows bigger than polynomial, but you need to like rigorous proof. Okay, so actually this can be proved by mathematical induction. So let's just write down induction. So the first step is that I consider case 0. Right, so case 0 is trivial. Okay, hope you can prove it. Right, so you can check that this guy goes as n goes to infinity 0. This can be, you can directly prove by using the epsilon delta argument. Or you can just write prove this by using the limit argument. Right, so you can easily show that you need to show that this guy will arbitrarily small, right? So you can prove, you need to make an argument that this guy can be arbitrarily less than epsilon. So which means that if you just choose n to be like 1 over epsilon, or n, you just choose c to n greater than 1 over epsilon, and then you can choose n to be greater than log c1 over epsilon. Okay, and if you choose n enough, large enough, then this guy will be true. Okay, so this guy you can directly prove it. So the next step is that we need to make a reduction, make an induction. So I can suppose that I can just suppose that n to the k, c to the n goes to 0 as n goes to infinity. Then for fixed k, let's say for fixed on k, and I can consider like k plus 1. Okay, now I can use the Lobito rule. Right, so Lobito rule tell me this. So I do the differential on both on n, right? So I get this, and for this that I scale the same thing, but there's a log, natural log c with the natural e basis, and now we take n goes to infinity. Okay, and okay. So okay, so what you get is the following, right? So because you fix k, right? You fix k, so this guy will be just k plus 1 log ec, right? So this guy is just constant times n to the k, c to the n limit, then goes to infinity. So this guy goes to 0. Okay, so which make induction correct. So we prove the first one. Okay, the second example is the log n squared plus 1 is the theta of log n. So let's do some trick. So the second problem is that we need to show log n squared plus 1. That's for convenience that use log 2 as basis. And there is theta of log n squared. Okay, so all we yeah, so and obviously that is just theta of log n, because this is log n squared just 2 log n. Okay, this is very simple. Right? So the idea is that let's say consider n greater or equal to 2, then you know that log n squared plus 1 is greater or equal to log n squared. And obviously that is checking n to n cube. Okay, you can prove n squared plus 1 less or equal to n cube for n greater or equal to 2 using mathematical induction. So this proves that you get 2 log n that's equal to log 2n plus 1 squared, and then that's equal to 3 log 2n. Okay, so the proof is just this. Okay. And okay, so yeah. Okay, so third one is that the log n alpha is the big O of n beta. Okay. Okay, so the third one is that the third one is tricky, a little bit tricky. Okay. But it's also a common one that okay, so let me just check again. So it's a log n alpha is big O and beta. Okay, so O of n alpha is the big O of log n n to the beta. Let me just clear this. By the way, sometimes I just since I finish all my daily work and I go to be on this type of video, so sometimes I will like get stupid. So I hope you guys, yeah. Thanks for you guys for the tolerance. Okay, so log n alpha is O and beta. Okay, so obviously that yeah, we need to like consider beta greater or equal to 0. Okay, sorry, greater or equal to 1. For 0, that is constant, right? Log n, and the alpha should be like greater than greater. If alpha is less than 0, then sure this will be true. So this is the region that we should consider. Okay. Sorry, greater than 0. If alpha is 0, then just both the constant and constant. So it doesn't make any interesting case. So this is beta equal to greater than 1, and the alpha need to greater than 0. Okay. Okay. So what this is something, right? So what we need to what we actually one can okay, so that's okay, so we let's say we can show the following. The following is the what we want to show is that the log n alpha is equal to n of beta for large enough alpha. Sorry, for large enough n. Okay. So in order to do this, let me just so this is equivalent to alpha log n. Let's say I take log. Okay, so I can let me just take log. So let me just take log. So when I take log, I get alpha log n. That's equal to beta log n. Okay. And so let me just set this to be t. So this is alpha t that's equal to beta exponential t. Okay, so now everything's simple that I can let gamma to be like beta alpha divided by beta. So I will get this this is the same as gamma t minus exponential t that's equal to 0, or the exponential t greater or equal to gamma t. Okay, for large enough t. Okay, so if this is true, then this will be true. Okay, by definition. Okay, so exponential t greater or equal to gamma of t is simple by 1. Okay, by the first one. Okay, and you or you can use whatever like calculus to prove it. Okay, so yeah, that's it. I think I don't want to. I think you can use calculus to prove it, but it's the same as the first one. Okay, so see you guys next videos. Hope you guys subscribe to my channel.